Alright, hello everyone. You'll notice things are a little different today. I had to go back to the US and I'm making this recording independently of the class itself, so if there are things that I miss, I apologize. Welcome to Beginner Java. I have no idea what lesson this even is, but we're covering objects today. We're going to start using an integrated development environment, or an IDE. It's basically a big, giant, fancy program to write code in. We're going to be covering what are classes and objects, which are really what make Java Java. We'll be covering access modifiers, which you've seen a little bit of already, and we'll go over creating objects, creating constructors for objects, and these sorts of things. So there's going to be a good little bit of theory involved in addition to actually writing some code. But the core of today is more of the theory, understanding what objects are, how to use them, and why they're useful. But first, let's start using an integrated development environment, because that will help us write code a little bit easier when we have multiple files to manage. So let's get started. Personally, I use IntelliJ. That is my favorite. A lot of people use Eclipse. A lot of people use NetBeans. There's several others as well. There are some people who even just use Sublime Text or Atom like we've been using. But for purposes of this class, we're going to use IntelliJ because that's just what I happen to know, and teach what you know, right? So what you want to do is you want to hop on Google and you want to search for IntelliJ Community Edition. There's actually two versions of IntelliJ. There's IntelliJ Professional, Ultimate, sorry, not Professional, IntelliJ Ultimate and IntelliJ Community. Ultimate costs you money. Community does not cost you money. You can see a feature comparison down at the bottom here, but the community version is what you are looking for. So I'm going to click the button, and then it'll go through and install. At this point, you probably want to pause the video. I already have IntelliJ installed, so I'm just going to dive right in. I'm not going to wait for this to download on this very slow network. So let me open up IntelliJ, and we'll get started with how to use this and why it's useful. Doo-ba-doo-ba-doo, doo-ba-doo-ba-doo-doo-doo-doo. Come on, you can do it. I believe in you. Alright, it's not going to look like this when you first open it. It may prompt you for like settings and all that sort of stuff. Unfortunately, I don't have a fresh install, so I'm not sure what settings you might be prompted for. But just read through things slowly. If you have questions, you can always ask us in Slack or on Kakao Talk. So once you get past any initial settings that there might be, you should show up at a page like this. Chances are your list on the left here will be empty because you haven't started any projects yet, but don't worry, we'll fill that up pretty quickly. At this point, you want to create a new project. We'll go over these other things probably not until intermediate Java, honestly. Though we may, if we toss GitHub into this course, we'll do this button, but we're not going to worry about that for now. So first we're going to do create new project. And you're going to get this big, giant, crazy thing. We're not going to worry about this. You just want to pick Java project, and you want to make sure that it's choosing Java 1.8, because that's what we're on. And then you just want to keep hitting next. Next. You want to give your project a name. In this case, I'm going to call it, what is it? Beginner June 2017 objects. We're going to go with that. You'll notice once you fill in the project name, it'll fill in the location automatically for you. If you set this folder right here, that will be kind of set as your your workspace folder, and I believe that it will preserve that for the future, and then any projects you create will create a folder within that folder. So remember how I've been telling you over the past several weeks to basically have kind of your Java learning folder, your Java workspace? This is why. Because now with IntelliJ, you can have all your projects in that one folder, and IntelliJ knows about them, and it's very easy to kind of navigate through things and check them out and play with them. So again, just pick your project location. If you don't know what the path is off the top of your head, you can click these ellipses, these triple dots at the right side, and it'll let you navigate through just like normal. Okay? So pick your folder, and pick the parent folder, hit OK, and then if you enter Oh, did I just make a liar on myself? Yep, I did. Well, come on. What is wrong with my... Oh, my keyboard is giving me woe. But once you get that set up, it should be easier in the future. Now you'll see module name matches my project name, content root, and module file location match the project folder. And project format, I never touch that. Idea is fine. So you should have something like this. Hit finish and you should be good. It does not exist. It will create the directory. Cool. Do the thing. Don't worry about this. Now, your IntelliJ should look something like this. You might get some pop-up about tips. You can read through tips if you want to. Honestly, I recommend it. I probably should, and I haven't yet, because it gives you all sorts of nifty little tools about how to use IntelliJ a little bit better. And better is good. So on the left side, you may see this project pane. If you don't, you can go to View, Tool Windows, and Project. Or you can hit Alt-1 on Windows, Command-1 on Mac. And then you should see your project name, and then external libraries. So external libraries is basically all of the Java stuff, and you don't got to worry about it. But this folder is our project folder, and this is where our cool stuff is. Now, this .idea folder, this has all of your files that define what the project is for IntelliJ. This is not part of your code. You generally don't want to mess with this. IntelliJ, also called IDEA, if you haven't figured that out already, IntelliJ will edit these files itself, and it's for its own tracking. You don't need to touch it. You don't need to worry about it. The same with this IML file. It just has a bunch of settings around how to define the project. So you can effectively... So you can effectively ignore it. What we really care about is this source folder. You'll notice how it's blue. Oh, and SRC is short for source. Fun fact, the code that we have been writing is called source code, right? You have source code and you have bytecode. Source code is the code that we have been writing, and then bytecode are the class files, the binary files, which are produced when you compile. So if you ever hear source code and bytecode, it should be a little bit familiar now. So from here, you got this source. If you right-click here, you can go to New, and you see all of these things. Now, there is one thing we have been ignoring when we've been working on our projects. Java has the idea of packages. I mentioned this a little bit in the past. But packages are basically ways to organize your code. Packages are equivalent to folders. And let's just go ahead and create a package so you can see what that looks like. So I'm going to create a package, and I'm going to call it org.learnteachcode.soul.java class.objects. And I'm going to hit OK. Now, why did I do the dots? You can think of a package name like a reverse domain name. So if we had learnteachcode.org, your package would likely be org.learnteachcode. Right? And that's actually exactly what I did here. Now, the cool part is that if you look at this on your, show in Explorer, if you look at this on your file system, you'll see that each of these is a folder. Okay? So a package is really just a fancy name for a folder, and then each folder is separated by the dot. Okay? You can think of the dot as just another folder. Alright? So now, why did we make this package? Well, you use folders on your computer to organize your files, correct? You use packages in a project to organize your code. It's the same thing. So I want you to get in the habit of creating packages for your projects, and they should follow some naming convention like this. And that way, it gives people an idea of like what organization created the code, what project it's a part of, or what department it's a part of, these sorts of things. So get used to that. From here, we're going to right-click, and we're going to go to New Java Class. And we'll just give it a name. Let's call it... Oh, geez. Naming time. I need to think of... Let's call it Piano. I have no idea why that... Actually, no, I know exactly why that popped in my head. But, now check this out. This looks a little familiar, right? We've actually been writing objects and classes already. I've just been kind of glossing over it. Now you'll notice that at the top here you have this package declaration. This tells Java that it expects to be in a folder structure like this. So it should be inside some objects folder, which is inside a Java class folder, which is inside a Seoul folder, and so on and so forth. And then you'll notice this public class piano. That seems really familiar, right? You'll also notice that the file name is piano.java. If we expand the package here, excuse me, I'm a little sick. You will see that the file name is piano.java and our class name is piano, just like I've been telling you guys for the past few weeks. It all matches up. Now IntelliJ wrote this code for us because it's just easier, right? Now, I actually made a mistake. We're going to leave this piano for now. Okay? So just leave this for a second. I want you to right-click your in the project pane. I want you to right-click your package name. I want you to go to New Java Class again, and this time we're just going to call it Main. Now, don't forget, I know I've been harping on you guys for this for a while now, but it's worth saying again. It is standard that your class names start with a capital letter. Okay? It's just how things go. Alright? So now here's a cool thing. If we would want to write a main function next, right? And I've been forcing you guys to memorize it, public static void main string args. Cool thing is that if you just type PSVM for public static void main, PSVM, ta-da! Do you hate me now for making you memorize that? Now, why did I make you memorize that? Because there may be times where you don't have a nice IDE to do these things for you. And this is probably a good stopping point for me to explain what an IDE really is. Now that I've shown you a little bit of value, you can create packages easily. It will generate some code for you. An IDE is short for an Integrated Development Environment. What the hell does that mean? Integrated means a whole bunch of things put together, so it's a whole bunch of things into one. Okay, so that's the integrated part. Development, we're doing development in it. And environment is kind of think of it as like a whole system that you work in. So it's a system that you work in for development that has a whole bunch of things put together inside it. What are these things that are put together inside it? Well, we have a fancy text editor, right? Similar to Sublime, right? It's not too different from Sublime, except it generates a little bit of code for you. It also has some package management, but remember earlier how in Sublime we would write our code in Sublime and then we would go over to our command line to actually run our program? With an IDE, you can actually run your program without having to leave the text editor. So let's demonstrate that real quick. So I'm going to do system out print line. Oh, you'll also notice code completion. Now this is a major benefit of IDEs. If I start typing system, you can see that this autocomplete box pops up for me, and I can just hit enter, and then I can hit dot, I can get out, I can do print, dot PR, print. You can see all the different kinds of print. I'm going to cover all this in a little more detail in a little bit. And I'm going to say hello world. Okay. Now this is nothing new. You guys have written this a few times already, but I just want to show you how to run this in an integrated development environment, specifically in IntelliJ. Now, unfortunately, some of the UI is not excellent. It's not very clear how you actually run this file. If you look at the top right-hand corner, you'll see this little drop-down arrow next to the zeros and ones. If you click this and you click Edit Configurations, this new window will pop up. It says Run Debug Configurations, right? If you hit this plus symbol at the top, we can say, hey, we want to do a new application. In this case, application is what we're looking for. And you'll see this main class, and you'll see this box. You'll also see ellipses at the end here. If we just click this, it will actually look through our project for a class that has a main method, right? Because if you remember, if you're running a Java program on command line, it executes the main method. So since we're running an application, which is suggested to be a command line application, it's going to look for some class that has a main function. So in this case, main is the only class within our project that has a main function. So it's going to kind of pick that for us. We just hit OK. And then we hit OK. We don't have to do any other configuration. You can give it a name if you want to. I'm just lazy. And then now you see you have a play button, you have a bug button, that's actually debug, and then you have this other strange button. Don't worry about that yet, okay? But if you hit that play button, it will compile your code for you, and it will run it for you. And now you can see it just says hello world here at the bottom, because that's what we did here. It's a lot easier than doing it on command line, right? But again, I wanted to teach you guys how to do it in command line because there will be days where you don't have a nice fancy IDE available to you. Okay? So, cool stuff, super awesome. Programming on easy mode, right? Now, let's go over some of the autocomplete stuff. If we do system.out.p, right? You'll see here basically a whole slew of options, but how do you read this, right? We have 50 different freaking print line functions and 50 different print functions. Like, what the hell is going on here? Well, just like a normal function definition, you'll see in parentheses some parameters. So there are different versions of the print function that we can use. The parameters here in parentheses, just like it would be in a function, and then the return type is off here on the right. Now print, since it prints to the screen and it doesn't actually output any data that you're able to consume, it's a void function, just like other ones that we've done. And we can just excuse me, you can kind of guess what's going on based on that. Now let's say that well, let's just start with this. Now, we have our main function, and I'm sorry, not main function. We have our main class, and we have our piano class. Right now, our piano class is empty, but that's okay. Now, we're going to use our piano class. But first, let me explain what, how, and why. So Java is what's called an object-oriented language. Okay, what this means is that code that you write in Java is meant to, or rather it's possible, or it allows, here we go, it allows you to represent real-world objects as code. And so it has kind of a structure that allows you to do that. In Java, objects have two things, really. They know things. You can think of knowing things as variables. They have attributes or properties, right? And they can do things. They know things and they can do things. Doing things is like your functions or your methods, like that add method we've written, or back in the calculator one, how we pulled that repeated code into its own method. These sorts of things. Now, so you're like, okay, cool, so I can have some object that knows how to do things. So we can, for example, on our piano, we can actually say that, hey, a piano has some number of keys, and we can say that you can play a piano. So let me just go ahead and demonstrate that real quick. So you know how earlier within our main function we would do something like int x equals 5, and then we would do like system.out.println, whoops, not println, x, something like that. We did this variable declaration initialization within our main function, but you don't have to do it there. What we can also do is we can just say that within a piano has some integer, and I'm going to call it number of keys. So piano has some number of keys. Now we're just going to declare it. We're not going to well, actually, you know what? Let's initialize it too. For some reason, the number 82 is sticking out at me. I'm not sure if a piano actually has 82 keys. That number is just popping in my head, and I'm really tired. So we're going to roll with that. And so whenever we have a piano, it's going to have some property. It's going to know something called the number of keys. And by default, it will be set to 82. And for now, we're actually going to set that as public. And I'll explain that public part in a little bit. And then we can also declare some function called play. It can take in an integer, and we're going to call it number of seconds. Oops, and we can say system out println played this piano for number of seconds. Okay, so now we have something like that. Now, this is a piano class which knows about its number of keys and has the ability to play. Now, this is the piano class. There's something that I need to make very, very clear to you. Classes and objects, you'll sometimes hear them used interchangeably. Sometimes people will swap between the two. But they do have very distinct, different, important meanings. You can think of a class like a blueprint. And you can think of an object like the building created from that blueprint. Okay? So we have a class of piano. Class is actually short for classification. So we have a class of piano, right? And then we can have actual specific pianos that fall under that class, under that classification of pianos, right? But each piano is the same when it's initially created, right? Because they share the classification. But each piano still operates independently of one another. So if I push the keys on one of my pianos, it's not like the piano next to it is going to start playing. What I do to one piano is completely independent of the other piano objects, even if they're from the same class. Just like how you construct two blueprints, just like if you construct two buildings from the same blueprint. If you open the door on one building, nothing's going to happen to the other building. In programming, the idea that you can edit data or interact with one object and it doesn't affect another object is the idea of encapsulation. Each object encapsulates or isolates its own version of data so that you don't have strange side effects. Okay, so that's kind of like the theoretical stuff, but how does this actually play out? Let's demonstrate. So I'm going to blow up my main method in my main class, and I'm actually going to create a piano object from my piano class. How do I do this? So just how with our other variables we have to give them a data type like integer, boolean, whatever. Piano, which is a class, is also a data type. Okay, so a class is a classification of objects, a classification of data. So I'm going to say that we're going to have a variable of type piano, and I'm going to call it my first piano. Okay. Now this would be sufficient. This would actually compile. However, I want to actually create a piano, right? This just tells Java, hey, a piano will be created, but we haven't actually created one yet. So now, in order to create a new instance of a class, a new object instance of a class, we have to use the keyword new. Okay, so I'm going to do new piano. And I have to do open close parentheses. I'm going to go into more detail about that later. So now, I can do something like system.out.println my first piano. And I can say system.out.println my first piano num keys. Okay. Now, so what we've done here, just to reiterate, is there's a class subobject called piano. There's a classification called piano. And I've created a new object, a new piano object from this class. Basically, the blueprint for a piano is the class, and then I've created an actual physical piano based on that blueprint, and I'm calling it my first piano. Okay? So now if I run this program, come on. You'll see when I try to print my first piano, it actually just gives me the full name of the class, which includes the package, and then it gives me the memory address it's stored at, which is not really important. It's just, you can think of it like a unique identifier, because you can't have two objects in the same spot in memory, unless they're multiple references to the same object, but whatever. And then you can see that the number of keys is 82, because that's what we initially set it to. Now, I'm going to make you trip out a little bit. I'm going to make my second piano. And I'm just going to kind of copy these lines. Ask you to excuse the yawning. It's about, I think it's 11 o'clock where I am now? Yeah, it's 11 p.m. where I am now. Okay, so I'm going to say my second piano. And what I'm going to do here is, I'm actually going to take my second piano, and I'm going to change the number of keys. I'm going to change it to 164. I don't know if that's actually a number of piano keys. That seems pretty huge, but we're going to roll with it, because random numbers. So now, and I'm going to take this my first piano printing, and I'm going to put it down here, just to kind of demonstrate a point. So now if I run this, you can see that whenever I print my first piano, I get the same memory address. Whenever I print my second piano, I get a different memory address, right? Because it is a physically separate piano. They were made from the same blueprint, but they are two different pianos. Okay? And then the number of keys is 164 on my second piano. But because that is encapsulated from any other pianos, when we print out my first piano, the number of keys remains the same, because the number of keys stored in that first piano is completely independent of the second piano. Alright? So that is the idea of encapsulation in action, where you can have multiple objects from the same class, but you can make changes to one object, and it does not affect other objects. Unless, of course, you wrote code for it to do so, but that would be messy. Excuse me. Oh, we can also play the pianos. Now, there would be effectively no difference between each of the two pianos, because they're not using any data that's stored specifically in the piano, so don't really need to do that. There's nothing to demonstrate there. So we've covered creating objects. Let me look at the syllabus again. I am so sorry. I'm incredibly tired. Ooh, we're good there. Was a class, was an object? Access modifiers, yes. Now, I'm going to show you something awesome. Are you ready for this? Right now, number of keys is public. If I change it to private, boom! This will not compile. Why? Why doesn't this compile? In Java, there's the idea of access modifiers. Basically, single word modifiers, single word modifications for objects, methods, variables, all these sorts of things. Sorry, classes, methods, variables. That allows you to control whether other objects or classes can actually see these things. Now, when something is public, anything can access it, okay, from anywhere, all right, within your program. Private means that no other object can access it. So now, when we do my first piano, when we try to access the number of keys, that doesn't fly, because number of keys is private, so it's not going to allow it to happen. So that's a little bit messy, right? Now, we could also do what's called package private, right? Which is we can leave out any sort of access modifier. And at this point, any objects that are in the same, any classes that are from the same package can access this variable. Now, if we look on the left side, main and piano are in the same package, so this works. However, if I make a new package within this package, let's call it instruments. Okay, and if I move piano to this package, yep, I know, go ahead and do it anyway. What's going to happen here is number of keys, since there's no access modifier, is only accessible to classes in the same package. But now piano is in the instruments package. It's not in the objects package. So main still cannot access this variable. Not going to happen. No joy. Okay. So that's private. You got public. This is package private. And then there's also protected. Protected means that yeah, okay, still doesn't work. It means that anything in the same package can access it, or any subclass, any child class. But we haven't covered that yet, so don't worry too much about it yet. Okay? So you can think of it this way. Public, any object can access it. Private, nothing else can access it. And no modifier, which is package private, is only objects in the same package can access it. Now, here's the thing. When we say access from that perspective, we mean both read and write. What about cases where we only want other code to be able to read the data? We don't want other code to be able to change it. Or we want other code to be able to write it, maybe, but not be able to read it, which sounds backwards, but there are cases where that's necessary. What you can do, and what honestly is recommended, is that you set this as private. You set it as a private variable, and then you do what's called a getter method or a setter method. So let me show you an example of a getter method. I can do public, and in this case number of keys is an integer, so I'm going to return an integer, and I'm going to say get number of keys. Now IntelliJ is smart. It knows what a getter is, so as soon as I start typing get, it's going to autocomplete for me any variables that are in the class. And it would take no inputs, and all it would do is return number of keys. Now, here is the thing about this. By doing this, we allow other objects to access the number of keys. We allow other objects to read the number of keys through this getNumberOfKeys method. But because the variable is private, and because we haven't provided a method that allows us to modify the variable, nothing else can write to this variable. Okay, nothing else can modify the value. So we have effectively made this variable read only. So now if I go to here, and instead of doing number of keys, I say get number of keys. And let's not forget to add a parentheses at the end because it is a method. Oh, and this line will no longer work because we can't set the number of keys. And there we go. Now it works again. Now that we're using this get number of keys method, which is called a getter. Now, we could also do a setter. Okay. Now, this would allow anyone who's accessing the piano object to change the value for number of keys using this method. Now, you might be wondering, okay, if I define a getter and a setter, a get method and a set method, what's the point of making it private at all? Well, one major thing is reusability. Because let us say that you want to track the number of times that reading the number of keys happens, right? If you just make it public, you have no way to do that. But if you use a getter, you have a way to add in that functionality. Let's first let's show set number of keys. I'm getting a little ahead of myself here. Let's show off set number of keys, and then we'll dive into that use case. So now we commented this out because we couldn't set directly. But now we can just say set number of keys, and we're going to do this. And now if we run it, whoops. Oh, setters should be void, most often. Now, you can see that the second piano number of keys is 164 again, because of our call right here. Now, you'll notice I use this keyword. This refers to the current instance, the current object instance of the piano class. Okay? Now, why did I use that? And why didn't I use it here? Well, here, it's obvious from the context that the only number of keys variable that I'm talking about is from within the class. But here, you'll notice that I gave the input parameter the same name as the variable on the class, right? So how would it be able to distinguish? By doing this .number of keys, I'm saying, hey, I want to do something with the number of keys on this piano object instance. Whereas if I omit this, it's going to assume that I'm using the parameter number of keys. And so what I want to do is I want to change the number of keys on this object instance to what was given to me, and that's what this line right here does. Okay? Now, given that, man, we are burning through this super fast. Let's go back to our counter example. So you may initially be thinking, oh, this is no different from setting it as public. However, let's say I wanted to track how many times a number of keys was called. I could have some private integer called count keys getter. And it's going to start at 0. And then within this getter, I can just say count keys getter plus plus, increase it by 1. Then I could add another method for the count keys getter. And now, there will be no change visibly because I haven't printed anything yet. But now on my first piano, we can see that we've called that getter method twice. Whereas if we had just set number of keys to a public variable, or to a public property, public attribute, whatever you want to call it, there would have been no way to do this. There would have been no way to track this. There would have been no way to increment this counter whenever it was accessed. Okay? There's other things you could do too, like let's say we wanted to take some action whenever the number of keys was set. Right? We could do the same thing there. So a good practice is to use mostly private variables and then public or package private or protected methods. So that's pretty much access modifiers in a nutshell. Oh, the same can be done, the same rules apply to methods. So if I made this get number of keys as package private, you would see that main would have all sorts of errors because it no longer has access to that function because it's not in the same package. Same thing if I was to do private. Private means nothing can access it. So any references to that method for main are going to fail. We're going to get all the red squigglies. However, if I make it public, I'm saying that anyone can access this method. Anyone can get the number of keys. And in that case, no red lines. That's okay because then anyone can access it. It's not a problem. Excuse me. Let's check the curriculum real quick. So we covered access modifiers. Creating objects. We kind of did that already. Whenever you do new, you're creating a new object. So we did that twice. We did it with my first piano, and we did it with my second piano. Okay. Now that just gave me an idea for how we can improve our calculator. Maybe we'll do that a little bit next week. We'll see. I'll talk with Ben. It covers pretty much all that part. Let's go back to syllabus one more time. Yeah, so we did creating objects. Constructors. So now, let's say that we did not want people to be able to modify the number of keys on a piano after it's been created. Right? And I mean, that kind of makes sense, right? Like, you get a really expensive piano from the warehouse. You probably don't want to be messing around with the number of keys on the piano directly. That's, unless you have very specific interests or reasons for getting the piano, that'd be kind of wasteful, wouldn't it? So, I'm totally rambling. Wow, I'm tired. I am sorry that you have to deal with me like this. Excuse me. So we only want the number of keys to be set when the piano was initially created. So let's get rid of the setter method. We don't want it. However, in this case, the default is 82, but now we don't have a way to change the number of keys on this piano. Well, the beautiful part is that in pretty much all object-oriented programming languages, there's the concept of what's called a constructor. It matches well with the blueprints and building metaphor, because the constructor method is the method that's executed whenever you create a new object from the class. So basically, when you have your class blueprint and you want to create your building from that blueprint, the constructor is the process that actually makes the building based on the blueprint. So you can define your own constructor to take special actions whenever you create a new object from the class. The way it works is you can basically just do public piano. And in this case, I'm going to give it, just like before, it's going to take in some number of keys. I'm going to say this number of keys equals number of keys. Okay? And at this point, you can actually go ahead and set these to blank here. And I'm just going to do this dot count keys getter. We're just going to start that at 0. So now, these things take place whenever a piano is created. But let's say that I still want to have kind of a default number of keys, because now that we have things this way, there's no way to do a default number of keys. Well, we can solve that with overloading, just like we used to in the past. So we can have a version of the piano constructor that takes in no inputs, and when we see this, we can just call we can just do this. Now, remember how this is referencing this object instance? In this case, it's also a way to access the constructor, right? Because this is referencing piano. And if the constructor's name is also piano, you can just say this. And when you call it as a method like this, then you get, well, then you can effectively call this method and it's overloading. Okay, because we have the same signature except a different number of parameters. Or rather, the same method name, but it could be a different number of parameters and it could be a different result. Now you'll notice that in our other methods we have to specify the return type, but for constructors we don't need to do that, because since it's a constructor, it's returning an object instance of this class. So that's implied you don't need to provide a data type, a return data type. Okay? So now with this, you can see set number of keys is no good anymore. However, because we have that constructor that allows us to specify the number of keys, ta-da. Now here's another cool thing. You'll notice that it says number of keys here. That's IntelliJ doing that, right? This would not happen in Sublime Text. This is IntelliJ kind of showing you like, hey, here's the name of the parameter that you're setting. So now we'll actually have code that will run exactly the same, because we haven't made any functional differences. It just works differently under the hood. Okay, so these are examples of constructors, kind of a basic constructor and then an overloaded constructor. Just like you can overload any other method. And is that, wow, that is, we just burned through that. I'm going to ask you if, please, since I went through this so quickly and I'm very tired and I'm sick and I'm not in a familiar environment, if I went too fast on anything or I didn't explain concepts well, and this is always true, but I just want to highlight it right now, please comment, give us feedback. Either comment on the YouTube video or comment on Meetup, or tag me on Slack and be like, yo, Beej, your shit sucks. Give me feedback, and if it's something that can be fixed with an annotation, I'll do that. If it's something that causes me to re-record it, I may or may not do that, because recording tends to be a lot of work, but this was actually pretty fast, so I don't know. So let's, hell, did we really cover everything? Man, we burned through that so quick. Makes me terrified that I left some stuff out. Okay. Are there any IntelliJ tricks that I can show you? Oh, let's just show some, since we have so much time, let's go ahead and just show some random useful IntelliJ stuff. So, yes, we have this little run dialog, or run options at the top right, that allows us to run our program very quickly instead of having to do all sorts of command line stuff. But let's say you still wanted to do things on command line. IntelliJ actually has a command line built into it. If you go to View, Tool Windows, and you go to Terminal, you can actually just run command line directly within IntelliJ. So that's a thing. If you're familiar with Git, VCS is short for Version Control System, and you can do Git stuff in here. If you're not familiar with Git, don't worry about it. But yeah, you can always do Enable Version Control Integration if you want to do Git things. Oh, other cool things. You'll find that lots of times maybe you didn't give a method a good name or something like that. If you do, I think it's Shift F6 on Windows, and I think it's also Shift F6 on Mac. That is the rename shortcut. So now I can say play 4 seconds. If I do this, anywhere that method is referenced, it will update that file to use the new name as well. So you don't have like, oh, I changed it in this file and I need to go change it in 10 other files. IntelliJ actually makes it a lot easier for you, just Shift F6. If you can't remember the keyboard shortcut, you can just right click and you can go to refactor. And then you have all of these wonderful options. Now you'll notice that some of these have like key combinations next to them. Those are your keyboard shortcuts on how to change whatever it is that you want to change. Those are also configurable, but I'm not going to go into that. You can define your own custom configurations for stuff. I actually did it so that I could have a lot of control with my fancy mouse. But you get the idea. You'll notice that this is that the text is gray and that it's underlined in gray. That means that the method's actually unused. We never actually used this play for seconds method. So IntelliJ just wants us to get rid of it. It's not used, why should it be there? Clean code is good code. So cool thing is that whenever you have kind of squigglies underneath something or something strange, if you hold Alt, or on Mac I believe is it Command or Control? I forget if it's Command or Control. Apparently it's Alt Return for Mac. It gives you options, and in this case it wants to safely delete play for seconds since it's pretty sure that it's unused. So if I hit that, it's going to ask me if I want to search for any usages of it before I delete it in case there's any special changes I need to make. I can hit OK. It doesn't find anything, so it removed the method. There we go. Remove dead code easily. That was what? 2 keystrokes and 1 click? Not bad. Oh, 3 clicks if you're including highlighting the text. But yeah, that's actually pretty much it. We just totally burned through that. Huh. Yeah, honestly, I got nothing. I apologize that this video is, well, actually short is good as long as you get all the information you need. But I apologize if you did not get all the information that you need to properly understand classes and objects. But just to review, today we covered where to download IntelliJ and some basics on how to use it. We didn't really cover installation because if I remember correctly, installation is pretty straightforward. And we then covered creating a new project. It's very simple. You pretty much just give it a project name and a location. We also covered how to create packages and what the purposes of packages are. We covered creating a class in IntelliJ. We covered setting up a run configuration in IntelliJ. And then we covered creating a separate class and creating new instances from new objects and instances from that class using the new keyword. And then we proceeded to change some of the access modifiers on the class to make it a little more secure, and to add getters and setters so that we could change things independently while still maintaining control. And then we covered constructors. We covered access modifiers, so like public allows anything, package private is only things within the same package, and private means nothing else. And we covered, oh my god, brain. Oh, we covered encapsulation within objects. Changing one object does not affect other objects of the same class, unless you coded it to do so. It's not a default behavior. And we covered constructors, the method that is used to create an object instance of a class when it's created. So at this point, I think we've pretty much covered everything I intended to cover for this class. That was crazy fast. So if you have any feedback for me, like maybe I spoke too fast, or maybe I missed some details, or maybe I was flat out wrong on something, I would love to hear it so that I can improve next time. Even if it's something like, Beach, you're sick, go to sleep, why are you staying up late recording videos? You should still give me that feedback, but I reserve the right to ignore it. But seriously, if there's anything I missed or any questions you have, just go ahead and comment or send a message, and I will do my best to clear it up for you. Beyond that, it is, 12:37 p.m. in Seoul right now, so I hope everyone's enjoying their lunch. And I hope everyone enjoys tomorrow's class. Ben will be teaching tomorrow's class. And if I can, I will attempt to remotely support. And yeah, I miss you guys, and I look forward to seeing you when I return in late July. But again, thank you for watching, thank you for continuing to join us, and we hope to see you next time. Alright, thanks everyone, good night.